Friends, welcome to the session, the continuation of chapter 5. Now in this session I am starting the three-phase power measurement. Okay. Now we'll see, before starting, how to measure the three-phase power using wattmeters. First I want to give some minimum points with respect to three-phase power that you already know with respect to three-phase system. I am not discussing in detail the formulas, that minimum knowledge that you know. With that assumption only I am explaining the how we can measure the three-phase power using wattmeters. Okay, but in a three-phase, mainly you have the two types of loads. One is star connected, another one is delta connected. Star connected and delta connected. Okay. Now in a star connected system or in a star connected load, you know the relations. Line to line voltage equal to √3 times of phase voltage, then line current is equal to phase current. One more point also you remember, line voltage leads the phase voltage by angle of 30 degrees. This you know. Now if you take in a delta connected system, what is the line current equal to √3 times of phase current, then what the line voltage equal to phase voltage. But in this case line current lags the IL lags I phase by angle of 30 degrees. This minimum knowledge you know. It may be star or delta connected system. In a three phase, how to write? Three phase active power equal to √3 VL IL cos pi. Is also written as 3 into V phase I phase cos pi. This is three phase active power. It may be star connected or delta connected. Formula is same. What is the formula for three phase reactive power? Three phase reactive power is equal to √3 VL IL sin pi. You also write 3 into V phase I phase sin pi. You write one more formula, three phase apparent power. How to write three phase apparent power? Three phase apparent power is equal to √3 VL IL. Once you know the active power and apparent power, then how to calculate power factor? That this is apparent power. Power factor equal to active power by apparent power. This gives the power factor. We know that all the phase voltages are displaced by 120 degrees. In three phase, all the phase voltages are line voltages. Phase voltages are displaced by 120 degrees. Okay, this minimum knowledge you know. Okay, this is the relations in star connection, and this is the relations in this you studied in three phase systems in circuit theory or network theory concept. Okay, then with this minimum knowledge, first I want to explain 3 wattmeter method. To measure the three phase power, we concentrate on 3 wattmeter method. For measurement of three-phase power, first we'll start with 3 wattmeter method. Three wattmeter method of power measurement. But I want to explain this concept for simplicity. By taking the resistive load, I will explain this concept. But with respect to 2 wattmeter method, I will explain using inductive load. Okay. If you want to measure the three-phase power by using 3 wattmeter method means for each phase we can connect 1 wattmeter. Okay. Let us assume that it is a star connected load. It may be star or delta connected load. The final power measurement is same. Only voltage and current relations will be changes. This is the star connected load. For simplicity, I am taking the resistive load. That this is the star connected. Okay. Now, for each phase we can connect 1 wattmeter. Yes. We connect for each phase, we can connect 1 wattmeter. Yes. Let this is neutral point or common point. This is neutral point or common point. Like this, for each phase we are connecting 1 wattmeter. Let I explain this concept for RYB phase sequence. This is R, this is Y, this is P. Always the phase sequence is taken in clockwise direction. This is R, Y, B. Vector rotation is always in anti-clockwise and phase sequence is always in clockwise. This R, this is Y, this is P. This is W1 and this is W2, this is W3. This concept throughout analysis I will explain for RYB phase sequence. If the phase sequence is changes, how the wattmeter readings will be changes, directly how to write also, that I will explain later. Okay, this is R, this is also R, this R. We are considering balanced loads. This voltage is VR, yes, this voltage is Vy, and this voltage is Vp. Okay, this is C is common point. We taken this is common point. Let us assume that common point is available. Yes, this is R, this is Y, this is B. Let this is R, B, Y, but the phase sequence is in clockwise, R, Y, B. Okay, then this voltage is V, R, Y. As for phase sequence I am giving, this voltage is VYB. This voltage is VBR. I am giving these voltages as per phase sequence. In RYB phase sequence means, I am assuming that RYB phase sequence means, then you take RY, YB and BR. Like this I taken. That's why RY, YB, BR. Okay. Now, let this current is IR, this current is IB, and this current is IY. Now, to measure the three-phase power, let's assume that if the neutral point is or common point is available, for each phase we can connect one wattmeter. The sum of the 3 wattmeter readings gives the three-phase power. Now, this VRY, VYB, VBR, what these voltages? Line voltages. These are taken as a line voltages. VR, VY, VB, or VRN, VYN, VBN. These are taken as phase voltages. These are phase voltages. Okay. Then what about IR, IY and IB? This IR, IY, IB is equal to line current is equal to phase current because of which load? Star connected load. This IR, IY and IB is line current that is equal to phase current because of star connected load. Now tell me, what is the reading of each wattmeter? In this, what is the reading of each wattmeter measured? Yes. What is the reading of each wattmeter? What is the W1 equal to? I told already, wherever we are calculating wattmeter reading, pressure coil reading into current coil reading into power factor. What is the pressure coil measure? Pressure coil measures only this voltage. VR. What is the current coil measure? Current coil measures this one. IR into power factor. Power factor is unity because of resistive load. VR into IR. Okay. That is pressure coil reading into current coil reading into power factor. Power factor is unity because of resistive load. Then similarly, what is the W2 equal to? W2. What is the pressure coil reading? W2 measures. This is VY into IY. Power factor is unity. That is VY into IY. What is the W3 measures? What is the W3? Pressure coil reading. What this pressure coil measures? VB. Okay. Then VB into IB into power factor is unity. That is VB into IB. But what is the three-phase power? Therefore, three-phase power equal to, how to measure three-phase power? Sum of the 3 wattmeter readings gives the three-phase power. Because for each phase we are connecting 1 wattmeter. That is the reason why sum of the 3 wattmeter readings gives the three-phase power. This is equal to VR into IR plus VY into IY plus VB into IB. Here this is the three-phase power measured by using 3 wattmeter method. That means, what is the observation here? In a 3 wattmeter method, for each phase we can connect 1 wattmeter. This is 1 wattmeter. For each phase we can connect 1 wattmeter. Okay, then it gives the sum of the 3 wattmeter readings gives the three-phase power. The three-phase power equal to VR into IR plus VY into IY plus VB into IB. Quick, note down this. Yes. Now there is one theorem is there. Now I want to explain what exactly Blondel's theorem. Blondel's theorem. This is important. Yes, that you concentrate. Listen please. For example, if the neutral point or common point is not available, if the neutral or common point is available, then you can connect like this. Okay, in a given load, if the neutral point or common point is not available, take any one line is reference. Take any one line. This R line, Y line and B line. Among all these lines, you take any one line is reference. Okay, let's assume that I am taking the line B is reference. Line B is reference. There is no any neutral point or common point is not available. Then take the any one line is reference. But here I am taking line B is reference. All these three are connected in one line. Okay. In that reference line, always wattmeter shows the zero reading. That means whatever the reference line you taken, in that line, whatever the wattmeter you connected, that wattmeter always shows the zero reading. Why that wattmeter always shows the zero reading? You tell me. I taken line B is reference. In that line, the wattmeter is connected like this. Okay. Then what is the wattmeter reading? Wattmeter reading equal to pressure coil reading into current coil reading into power factor. Then what the pressure coil measures? 0. Then always the wattmeter shows the 0 reading. Why the pressure coil measures 0? You tell me. These two terminals are connected on the same line. Whatever the voltage is present here, the voltage at this is also same. Because voltage across the current coil is negligible. It's just like a shorted. Then what is the voltage measured by the pressure coil? 0. Voltage measured by the pressure coil 0 means always that wattmeter shows the 0 reading. That means if the neutral point or common point is not available, we are taking any one line is reference. In that line, whatever the wattmeter is connected, always that wattmeter shows the 0 reading. Why that wattmeter shows the 0 reading? Because pressure coil reads the 0. Then every time the wattmeter showing the 0 reading means what is the use of that wattmeter? Remove that wattmeter. The wattmeter which is showing the 0 reading, then remove that wattmeter. Then by using 2 wattmeters also, we can measure the 3-phase power. This is the 2 wattmeter method of power measurement. Then I want to prove that these 2 wattmeters measure the 3-phase power. That means first you write the statement of Blondel's theorem. That is, if neutral point or common point is not available, if neutral point or common point is not available, common point is not available, take any one line is reference. Take any one line is reference. Any one line is reference. Okay. In that line, wattmeter shows the 0 reading. Wattmeter shows the 0 reading. Shows the 0 reading. Yes. Then remove that wattmeter. Then remove that wattmeter. That wattmeter. By using 2 wattmeters also. By using 2 wattmeters also, 3-phase power is measured. 3-phase power is measured. Then we want to prove that this 3-phase power is measured using the 2 wattmeters. This is Blondel's theory. Okay. Now, if 1 wattmeter is removed, then this is the 2 wattmeter method of power measurement. We can also connect like this. I am redrawing the circuit like this. This is a 2 wattmeter method of power measurement. Now in this case, can you tell what is the W1 equal to? I told so many times, wherever the wattmeter reading we are calculating, the wattmeter reading equal to pressure coil reading into current coil reading into power factor. Yes? Then what is the W1 you tell me? W1 equal to pressure coil reading. Pressure coil measures between R and Y, that is VRY. Sorry, VRB, between R and B, VRB into IR. But power factor is unity because of resistive load. This is into 1. That is VRB into IR. Similarly, what the W2 measures you tell me? This W2 measures VYB. VYB. This is VYB into IY into 1. That equal VYB into IY. Then can you tell me what is the W1 plus W2? W1 plus W2 equal to, that is VRB into IR plus VYB into IY. Then what is the W1 plus W2 equal to? Shall you write like this? IR into VRB is not VRB, you write according to vector notation is written as VR minus VB. IY into, as per vector notation, VY minus VB. Then how to write, you tell me? Therefore W1 plus W2 equal to VR into IR plus VY into IY minus, take VB is common, IR plus IY. We know that if neutral point or common point is not available, if neutral is not available, then what is the condition, you tell me? IR plus IY plus IB equal to 0. Then from this, what is IB equal to? Yes, IR plus IY equal to minus IB. Then you substitute IR plus IY equal to minus IB here. What the W1 plus W2? W1 plus W2 equal to VR into IR plus VY into IY plus VB into IB. Then what this power? 3-phase power. This is the proof. This is Blondel's theory proof. That means by using 2 wattmeters also we can measure the 3-phase power. By using 2 wattmeters also we can measure the 3-phase power. Okay, but this method is applicable. The condition is if the neutral point or common point is not available, then only we can apply the 2 wattmeter method. Otherwise we go for the 3 wattmeter method. Clear? Note down. This is the proof for Blondel's theory. This is a statement and this is the proof. We have proved that by using 2 wattmeters also we can measure. The same concept we can also prove that by using inductive loads also. But for simplicity I am explaining like this. Clear? That you concentrate. Quick note down. Yes, this is how to measure the power using 3 wattmeters. But according to Blondel's theory, there is one statement is there. For n-wire system, then how to select the number of wattmeters, selection of wattmeters to measure the power. Okay, this is according to Blondel's theory I am giving. Yes. How to select the number of wattmeters means you write as a note. This is a selection of wattmeters. First one, for n-wire system. For n-wire system, this is generalized statement. For n-wire system, number of wattmeters required equal to number of wattmeters required is n minus 1. The number of wattmeters required is n minus 1. Okay, this is generalized statement. Here it is not mentioned that minimum number of wattmeters, maximum number of wattmeters, balanced system, unbalanced system, like that it is not mentioned that. Generally for n-wire system number of wattmeters required equal to n minus 1. But even though conditions also given, minimum number, maximum number, balanced, unbalanced, in that case also this formula is applicable except one case. What is that case also I will give. Okay. For n-wire system number of wattmeters required is n minus 1. Yeah. For example, for 3-phase 4-wire system. For 3-phase 4-wire system, the number of wattmeters required equal to 4 minus 1, 3. For 3-phase 3-wire system, the number of wattmeters required equal to 3 minus 1, 2. Here why it is 3, why it is 2, then you can get idea. 3-phase 4-wire. 3-phase 4-wire means neutral is available. That's why 3 wattmeters. 3-phase 3-wire means neutral is not available. That's why required 2 wattmeters. Okay. But sometimes if the wires are not mentioned for 3-phase system, number of wattmeters required. Number of wattmeters required. If it is asked like this. Here wires are not mentioned. If the wires are not mentioned, you take 3-phase 3-wire only. That's why 3 minus 1. Directly you can write. If the number of phases also given, you take like this. 3 minus 1, 2 wattmeters. For example, for 6-phase 6-wire system, it is asked. 6-wire system. The number of wattmeters, whatever it is given, number of wattmeters equal to 6 minus 1, 5. N-wire, 6 wires, 6 minus 1, 5. If wires are not mentioned, if only phases are given, then you take that is directly as a wires only. Okay. Then like this we can select. But here it is not mentioned that minimum number or maximum number or balanced or unbalanced is not given. Directly we can calculate like this. But if minimum number, maximum number, balanced and unbalanced is given, then in that case also this formula is applicable except one case that you concentrate. See, 3-phase 4-wire, 3-phase 4-wire, this another note I am giving, 3-phase 3-wire, 3-phase 3-wire, yes, balanced system, unbalanced system. How to select the number of wattmeters? Then minimum and maximum. Here also minimum and maximum. Yes, tell me. 3-phase 4-wire balanced system, minimum number of wattmeters is maximum is 3. Here unbalanced, minimum is 3, maximum is also 3. Here 2, 2, 2, 2. This is the selection of wattmeters. How to select minimum and maximum number of wattmeters in a balanced and unbalanced system? See this one. Yes, except this one. Except this. In all the cases, this formula is applicable. Same formula is applicable. Except this one. This is n minus 1, 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 n minus 1. Is correct? 3-phase 4-wire. 4 minus 1, 3, 4 minus 1, 3, 4 minus 1, 3. 3-phase 3-wire. 3 minus 1, 2, 3 minus 1, 2, 3 minus 1, 2, 3 minus 1, 2. Only this is not applicable. That means, if it is mentioned that 3-phase 4-wire balanced system, if the neutral is present and if it is a balanced system, the minimum number of wattmeters is 1. Why? If the neutral is available, we can measure the single phase power. Because of balanced, you multiply into 3, then you can get the 3 phase power. It means using single wattmeter, first you measure 1 phase power, then into 3 you can do, then you can get the 3 phase power. That's the reason why if the neutral is present, if balanced is given, then you measure the 3 phase power, no need of more number of wattmeter, single wattmeter is enough. In remaining all the cases, then this formula is applicable except this one. Okay. For example, if the question asks like this, example I am giving, yes, that you concentrate. See one example. For 3 phase, 4 wire, balanced system, minimum number of wattmeters equal to dash, minimum number of wattmeters is dash. If it is asked like this, yes, 3 phase, 4 wire, balanced it is given. 3 phase, 4 wire, this neutral is present. Neutral is present, balanced system. Then minimum number of wattmeters is equal to 1. Because using single wattmeter we can measure the single phase power, we can do into 3, then we can get the 3 phase power because of balanced. If the question asks like this, for 6 phase, 7 wire, balanced system, yes, balanced system, minimum number of wattmeters is dash. If it is asked like this, then what is your answer? What it is given? 6 phase, 7 wire, 6 phase, 7 wire, extra 1 wire, neutral is available. Neutral is available, balanced system. Then minimum number of wattmeters equal to 1. You measure single phase power, into 6 you can do, then you can get the 6 phase power. Understood or not? Okay. Then if it is asked like this, for 6 phase, 6 wire, balanced system, then minimum number of wattmeters equal to dash, minimum number of wattmeters equal to dash. You tell me. A 6 phase, 6 wire, neutral is not present. It may be balanced or unbalanced. Then what is your answer? N minus 1. It may be balanced or unbalanced, N minus 1. That is 6 minus 1, 5. It may be minimum or maximum. Then your answer is 5 number of wattmeters are required. Like this we can select the number of wattmeters to measure the power. Okay, this is given according to Blondel's theorem. Understand? Quick note down. Okay, like this, you can set the number of wattmeters to measure the 3 phase power. Yes, one observation here before going to the 2 wattmeter method of power measurement. You see the one observation. I told already so many times, theoretically we are calculating the wattmeter reading means, then we can apply pressure coil reading into current coil reading into power factor. For example, let it is some load. It is connected some load. This is Z I'm taking about star connected, either star connected or delta connected. We can do like this only. This is Z. Okay. For example, if the current coil is connected like this and pressure coil is connected like this, if it is connected like this, then how to calculate wattmeter reading means wattmeter reading. Just understand, for understanding I am giving this note. Calculate wattmeter reading means current coil reading. Current coil reading is nothing but it measures the line current. But here line current is equal to phase current, because of star connection. If it is a delta connection, according to that you can apply the formula. You know the relations between line and phase in the star connection, delta connection. Line current is equal to phase current. But what about this pressure coil measures, you tell me? Yes, pressure coil is connected between line and neutral. Then it measures the phase voltage. Then you substitute the power factor. That depends on the load. You can substitute the power factor. That is different. Understood? See, during applying wherever we are calculating, this is very important. If any circuit is given, theoretically we are doing the calculation of wattmeter reading means pressure coil reading into current coil reading into power factor. This is IL, this is V phase, it measures V phase. Then you can write, it is a star connection now. If you want to write in terms of VL means, then V phase equal to VL by root 3, you write. If you want to write line, or otherwise you want to substitute directly phase voltage, you directly substitute phase voltage, no problem. First you see the wattmeter measuring phase voltage or phase current or line voltage or line current, that you substitute. Then according to that relations you can replace. In star, you know what is the relation in current and voltage, what is the phase voltage and phase current relation, what is the line voltage line current relations, that you know. Okay, according to that you substitute. Okay, this is like this. If wattmeter reading equal to pressure coil reading into current coil reading into power factor. For example, if any wattmeter connection is given like this, this is Z, there is some load. Let us assume that this is some load. I am taking the star connected. This is L, Z, and this also Z. Now, and pressure coil is connected like this. Pressure coil is connected like this. Now, in this case, what is the calculation of wattmeter reading? How to calculate wattmeter reading? Wherever you are calculating wattmeter reading is pressure coil reading into current coil reading into power factor. Then what is the current coil? This is connected in line. This is line current. This is also equal to phase current because of star connection. Then what this pressure coil measures? Yes. Now the pressure coil not measuring the phase voltage because it is connected between line to line. Then it is measuring the line voltage into power factor. How to calculate that power factor? Later on we will see. Then you can substitute the power factor. Understood? Based on connection of pressure coil, you can apply the formula. It may be even delta connection is given. For example, if a delta connection is given like this. Okay, delta connected load is given. Let the current coil is connected like this. Current coil is connected in one line and pressure coil is connected between two lines. Like this it is connected. Now it is asked what is the wattmeter reading. Wattmeter reading is current coil is connected in line. Pressure coil is connected between two lines. Then into power factor. Like this we can apply. How to calculate power factor? That by drawing the vector diagrams, and directly also how to calculate. All this later on we will see. Then first I am explaining the concept how you can calculate the wattmeter reading. Whatever the circuit it is given, this is the procedure only. It may be single phase or three phase. In three phase you go for the three phase formulas. In single phase you go for single phase formulas. Okay. Then this is connected in line current. This is line voltage. But here line voltage is equal to phase voltage because of delta. But here if you want to replace in terms of phase current means, then line current is equal to root 3 times of phase current, you can replace. Root 3 times of phase current. But this can measure which current? Line current. Understood? Okay, like this we can apply to calculate the wattmeter readings. How to calculate the wattmeter readings means like this you go for this procedure. Understood or not? Okay. This about how to measure the three phase power using the wattmeters. Using the wattmeter. Here for simplicity, first I am explaining the 3 wattmeter method of power measure. One more observation. For example, if wattmeter is, it may be some load, it may be star connected or delta connected, whatever may be. Let us assume that and pressure coil is connected like this. Then in this, what is the wattmeter reading? The wattmeter reading always shows the 0 reading. I told. Because the voltage across the current coil is negligible, whatever the voltage is present, this voltage and this voltage is equal, then what is the voltage measured by the pressure coil? 0. When the voltage measured by the pressure coil 0, then what is the wattmeter reading? Wattmeter reading equal to 0. Okay, this observation is important during solving of the problems. If you connected in a particular circuit, then based on the connection of wattmeter, how to calculate the wattmeter reading, that you concentrate. Okay. This is some introduction to the three-phase power measurement using wattmeters. With this knowledge, the very important concept in the power measurement using wattmeters is 2 wattmeter method of power measurement. How to measure the power using 2 wattmeter method, then what is the application of 2 wattmeter method, what is the effect of power factor on wattmeter reading, all these we will see. In the next session, we will continue with the three-phase power measurement using 2 wattmeter method. Thank you.